Hey guys, I'm here back with another math video. Today we're going to be doing an AMC 12B problem from 2014, problem 25. And take a look at the problem, see what you can do with it. And without further ado, I will go on to the solution. So, yeah. First of all, we notice that everything on the left side is cosine 2x, and the thing on the right side is cosine 4x. So we're going to want to rewrite that. Sorry. Cosine. Let's see if I can make my pen a bit bigger. Cosine 4x minus 1. And you should, the cosine double angle formula, let's see if I can remember it. I think that's equal to 2 cosine squared 2x minus 2, because cosine 4x equals 2 cosine 2x minus 1. And that's just the double angle formula because cosine 2 theta is equal to 2 cosine squared theta minus 1. That's just the formula you should remember. So now we have everything is in cosine 2x, which is better. And you know, since everything is in cosine 2x, we should probably, I don't know, it'd probably be substantially easier if we just subbed it out. So let A equal cosine 2x. So what do we get? Actually, what's interesting is that I don't feel like writing this over and over again, so I'm going to sub this out too. Squared over x. So when we simplify this, we get 2a, a minus, actually, I'm going to make it like that, so it's simpler, equals 2a squared minus 1, 2a squared minus 2ab equals 2a squared minus 1, cancel, wait, 2a, okay. Yeah. Oh wait, whoops. I mean that's what I did wrong. Sorry. This is a 2. So negative 2ab equals negative 2. So ab equals 1. Okay. That seems better. So let's think about this. For ab to be equal to 1, well, let's try let a equal 1 and b equal 1, and I think that will give so cosine 2x equals 1. So what is x? If x is any multiple of pi, this works, because cosine of any even multiple of pi works, and since we have a 2 here, we're guaranteed to get an even multiple. So long as x is some multiple of pi, and let's just say x is k pi. Let's just do that. So x is k pi, then b equals cosine 2014 pi squared over k pi. Yeah, okay. Again, this has to be an even multiple of pi. So 2014 pi k is even multiple of pi, since this equals 1, remember. So it has to be an even multiple of pi. 2014 over k is even, and 2014 is equal to 2 times 19 times 53, right? So k can, since we want if we divide this by 2, we get an odd number, right? So we don't want that. We want to divide it by if k is 2, right? Or any multiple of 2, like if k is 38, this becomes odd. So we don't want that to become odd. We want that to become even. So k has to be odd. So k can be 1, 19, 53, and what's 19 times 50? Oh yeah, 1007. So we already have like 4 solutions. 4 solutions right there. Alright. What else? So what if A and B are like, A and B are negative, A is negative 1 and B is negative 1. And I don't think there's any other cases, like if A is like 2 and B is 1/2, I don't think those cases, they just won't work. They just won't work out. We just want like clean cases, like, you know, like, yeah, I don't think it'll work out if A is anything else other than negative 1 or 1, and B is anything else other than negative 1 or 1. So let's try this. So cosine 2x is negative 1. What has to happen in that case? Well, in that case, we want this to be odd, right? So we want this thing to be odd, and for that thing to be odd, x is it's hard to explain. X is 3 k over 2 pi where k is odd. Yeah, that works, because if you multiply this into that and you multiply by 2, it gives you an odd thing here, which gives you negative 1. Okay. So b equals negative 1 equals cosine 2014 pi squared over k over 2 pi. That's equal to 4028 over k pi, and that has to be odd. Yeah, here's the thing. This has to be odd, right? Because if this is odd, then this thing is odd, and then b is negative 1. So this has to be odd. So 4028 over k is odd. But the problem is k is odd, right? We know k is odd. So if this can't be odd, because if you divide an even number by an odd number, you're going to get an even number. So this can't be odd if k is odd. So there's actually no solutions for this case. So we only have this case, and here are the solutions here, right? So if we actually add the solutions up, so 1007 plus 20, which is 1027 plus 53, get 1080. So the answer is D. So I hope you enjoy that problem. Merry Christmas, by the way. I'll see you next week. And to figure that out, you need to know some properties about similarities. So given two volumes that are similar, say this is a tetrahedron and you have a bigger tetrahedron,